Now it's going.
Okay.
Okay, so we're going to talk about one of the questions on the more groups worksheet. We're going to talk about the order of elements. So the first thing it asks us to talk about is that we had this notation a to the m, and we want to know why this is well defined. So if I have just m equals 2, if I'm looking at a times a, do I have to worry about anything being well defined here?
No.
No, it's fine. Right? We know how to multiply two elements in a group. This is okay. But what if we're trying to look at a cubed? This should be like a times a times a. But is there anything I need to worry about over here? What group axiom lets me do this in an unambiguous way?
Associativity.
Associativity. So it could be that I could have meant, let's do this. I could have put in parentheses like this. Or I could have wanted to instead put in parentheses in the other way, like this. But these should be the same because it's a group. And that means I'm allowed to just write a to the third and not worry about whether I mean the red parentheses or the blue parentheses. It's okay. Let's say it's okay because of associativity. Okay. So the second thing we're supposed to think about on this problem is we're supposed to think about what happens if we have two numbers and an m and we know that a to the n equals a to the m. It asks us to prove something about n minus m. Namely, that the order of the element a is at most n minus m. Well, what can we possibly do here?
Shall we use the inverse of A?
Okay, so I have an inverse for a because I'm in a group. So there's definitely this thing called a inverse. I guess what do I want to do with it?
Maybe we want to cancel one side to get the identity element.
To cancel one side of this formula here.
Yes.
So I guess I probably want to cancel the smaller side. The smaller side is m. So maybe I should multiply on both sides by a inverse to the m.
Yes.
Okay, so this is just another way of writing a to the minus m. So maybe I'll do that instead. To be a little more efficient. A to the minus m. And now I want to multiply this on both sides of this equation. Okay, well, on the right side, I know exactly what I get. What is it?
E.
It's just the identity element of my mysterious group. Okay, and on the left side, let's see, n is bigger than m, so I'm going to get a to the n minus m, which is some positive number up on the top. Okay. Well, here's the thing. This is true. Does that tell me what I wanted?
Yeah, I think so.
So what did I want? I wanted to know the order of the element a was at most n minus m. What does it mean for a to have order k or something?
Then A to the K should be E.
Yeah, and
the K should be less than or equal to n minus m. Here.
yeah. So the order of the element is the smallest exponent you can take, where you get back to the identity. So anything that you can take as an exponent that gets you back to the identity has to be at least as big as the smallest thing that gets you back to the identity. So n minus m is apparently the kind of thing that gets you to the identity. So it must be at least as big as the order of a.